Hey guys, welcome back. We'll continue with the book Cracking Codes with Python, and in this video we are going to learn about a more secure encryption method called Transposition Cipher. We are also going to learn about some additional programming concepts such as functions. Let's get right into it.
We learned that the Caesar cipher isn't secure. It's fairly easy to brute force and figure out which key is being used to encrypt messages. The transposition cipher, on the other hand, is more difficult to brute force and therefore more secure, since the number of possible keys depend on the message length. So let's first have a look at how the transposition cipher works. We first count the number of characters in the message and the key. Then we draw a row of numbers of boxes equal to the key, for example 8 boxes for key of 8, and then we start filling in the boxes from left to right, entering one character per box. So as an example, if we want to try to encrypt the message "common sense is not so common," we can for instance use the number 8 as a key. In general, we can use keys that are in between 2 and half of the message size, which in this case is 15, since our sentence "common sense is not so common" has 30 characters. So the longer the message is, the more keys are possible. Now to start out with a key of 8, we are going to draw 8 boxes, and then we're going to take our message and put each character in one of those boxes. We also include space characters as well as other characters such as commas and dots. We then continue adding additional rows and continue adding our message. So here for instance we have common space S in the first row, and then in the second row we would continue with ENSE space is space and so on and so forth. And we would continue doing that until our entire message is filled in. So the last 2 boxes here are grayed out, we can just ignore them. We just need them because we need to fill the remaining columns here. Now next we would construct a new message by transposing the message, basically starting reading the newly created text from the top to the bottom, one column at a time. So in this case we would start out with CENO, then we would continue with the second column ONOM, and so on and so forth. Taking this approach, we get this ciphertext here, and it's very hard to tell what the original message was. Now to create a program to encrypt our message and to translate that into Python, we need a way to transform our ciphertext that we created by hand into code. And for that we can reference each individual cell with a unique index. So we would start with index 0, 1, 2, 3 and continue doing that. So in the case of having a sentence with 30 characters, we would start with index 0 and go all the way up to 29. Now if we have a closer look at that, we can see that we have a certain pattern. If we have a key of 8, we would start with an index of 0. Then in the cell just below, we have an index of 8, then 16, then 24. And in the second column, we would start with index 1, 9, 17, 25, and so on and so forth. So as we go down one row, we always increase the index by the value of the key. So in this case, a value of 8. And this of course helps us to express this in code. So let's now switch over and write out a program that allows us to encrypt a message using the transposition cipher. For this we can open up idle, then select File, New File, and we're going to save this under the name transpositionencrypt.py. Now inside of our program we are first going to import the paperclip module, because that helps us to copy the ciphertext and for example to paste it into an email. And then we have 2 functions, first the main function that we define and then the encrypt message function. And we're going to have a closer look at it in a bit, but for now it's sufficient to say that we have a message that we add in here. So in our case our sentence "common sense is not so common," and we also specify a key that we use for encrypting that message. We are then going to call our encrypt message function, and we pass the key to it as well as the message. And we store that back in the ciphertext. And the encrypt message here is going to encrypt our message and store it back into ciphertext. We're then going to print out the ciphertext, and we are adding the pipe character at the end, just to highlight if there are some spaces at the very end of our encrypted message. After that we are then copying the encrypted string in ciphertext to the clipboard so we can for example paste it into an email. Now since we are calling the function encrypt message here with the key and the message, inside of our encrypt message we first create a list of strings. We have 1 string for each of the rows that we are going to work with. And to construct that we are simply going to multiply our empty string in the list by the key, for example by 8, And this way we're going to have 8 strings, and these are going to construct the individual columns of our transposed string. So for example, the first column here, the second, third, all the way up to the 8th column. After that, we are going to loop through each column in our ciphertext. So that means from 0 all the way up to, but not including the key, for example from 0 to 7. And we're gonna set the current index to that specific column, for example column 0 all the way up to column 7. We're then checking that our current index doesn't go beyond the length of our message. That means specifically, in this case here, we would stop at 29 characters because 30 and 31 would not correspond to any entries of our original message. Now within those bounds we reference characters inside of our message that we set up here, and we're going to assign that to the respective ciphertext column. We're then going to increment the index by the key, so this basically allows us to move from the first row to the second row and so on and so forth. And by the end of this we are going to have a number of separate strings that correspond to the key that we have. We are then going to join those strings together so that we have a single encrypted message. And at the end we have a short statement that we're going to cover in more detail in a moment, but it generally allows us to run our program and also import it as a module for other programs that we write. Now before we cover the details, let's actually run our program. We're going over to run and then run module. And we can see this is the output we actually create. We also copied this, so if we were to paste it, then we can see we have the same message here without that pipe character at the end. And this output here corresponds to the ciphertext that we created by hand. We can create our own functions by using the def keyword, followed by the name of the function and then parentheses. So as an example, we defined the main function before. Here we have the function definition word, def, followed by the name of the function, parentheses, optionally with some parameters that can be used, and then a colon. And everything inside of that function will then be indented in a separate block. We have a second function that we define called encrypted message, and other than the main message, this accepts 2 parameters, one called key and one called message. And by defining those parameters, we can then, when we call the function, actually pass arguments to it. So here we are passing my key and my message, those 2 variables we defined up here, as arguments to our function. And in order to do that, we need to first define the parameters. Let's have a quick look at how we can define functions by creating a new file. We are going to save this as hello function.py, and then we add our own function by using the def keyword, then the name hello, and we define one parameter called name. After the colon we indent the next line and we print the string hello, and then we concatenate whatever has been passed to name to it. We can then print start just to show that we start calling our function. We're calling our function with the argument Alice. Then we print call the function again, and we call the function again, this time with the argument Bob. So let's have a look at the output by selecting run and then run module. And we can see that indeed it prints out hello Alice and hello Bob, depending on what argument we pass to our function. Now with this covered, we understand how we define the main function here and the encrypt message. And everything inside of that function that is indented, so for the main function, this entire block of code here is part of that function and will be executed as part of that function. Now it's important to note though that changes to parameters exist only inside of the function. So as an example, we have a function here which has one parameter, and we're going to set that parameter to 42. We are then outside of that function define a variable spam and set it to the string hello, and then we call the func function that we defined, and we pass spam, the string hello, as an argument to this function. And then we print out spam. And if we have a look, we will see that spam has actually not been changed. It is still set to hello, and that is because the change inside of that function is only valid inside of the function itself. We have a local scope, so just inside of the function, and there's also a global scope outside of that function. And outside of the function, always the global scope would be applied. If we want to make a change to a value itself, then we would have to actually update the value of spam with the return value of this function here. And the scope of a variable can either be local or global, but not both. So therefore it's important to think about whether we are inside of a function with local scope or outside the function in global scope. Now another new concept that we learned about in this code is working with lists. Here we can see that we define a ciphertext variable, And we have a list here, which we can see by the brackets. And then we multiply that by a key to create a number of different strings inside of our list. So let's first have a look at how lists generally work. To define a list, we would use brackets, and inside of those brackets we add the different elements of the list separated by a comma. So here, for example, we have a list called animals, and that contains 4 different animals as strings inside of our list. The list itself is defined by brackets, and then the different strings here are separated by a comma. We can of course reference what's inside of that list by simply typing in the name of the list, and then we can see our list with the individual values. Similar to how we can reference individual characters inside of a string, we can reference specific elements in our list by referencing their index. So inside of our list we would start with index 0 for the first element, 1 for the second one, and so on and so forth. So if we have a look at the element with index 0 inside of our list, we will see this is indeed the first element that we defined. We can also use the slice syntax we learned about before with strings to reference multiple different list elements. So in this case here, for instance, we take a look at the elements from position 1, so the second element, all the way up to but not including the element with index 3. So this would mean 0, 1, 2, 3. So we should get back those 2 middle elements, which is returned here to us. We can also use the length function to determine the number of elements inside of our list. So here, for example, we can see we have a total of 4 different elements inside of our animals list. Similar to strings, we can also perform some mathematical operations on our lists. So as we saw before in our code, we can, for example, take an empty list and multiply it by the key, for example, a value of 8. And this is going to create a list with 8 separate entries, in this case all with an empty list. And this is how we construct the different columns of our transposition cipher, which we are then going to fill with the individual encrypted sections, the different columns, and by the end we are going to merge them together to have our encrypted message. And of course we can also concatenate different lists by simply adding them together, and this is going to add them to a single list. We then have a way to take the elements of our lists and joining them together into a single string. For this we can take an empty string and then call the join function on it, and here we're passing our list as an argument to it. And if we take a look at that, we can see it's going to take the elements of the list and concatenate them together to create a string. And this is how we take the different elements from the different rows of our encrypted message and add them together to create our encrypted message. Now with this additional understanding, let's go back to our code. And as we learned before, we define our main function and our encrypt message function. And our encrypt message function takes the key and the message as an argument. And inside of this function, we first define a list of empty strings and multiply that by the number of keys. This is going to add a certain number of strings to our ciphertext variable, which are stored in the list. And this is going to correspond to the number of keys. So effectively, we are creating those containers here for our individual characters to be added to. And we're going to have, of course, multiple rows of those containers, as we see here. So with a key of 8, we would have 8 columns. If our key was 15, for example, we would have 15 columns. And of course, in the beginning, basically, the entire structure here is empty because we only have empty strings. So therefore, we are looping through each column in our ciphertext. And then we are adding the plus equals operator to add the section of our original message with the current index to the appropriate column in our ciphertext. And the plus equals augmented assignment operator is basically just a shorthand for adding a certain value to an existing variable. So as an example, we have a variable here called number that we set to a value of 5, and then we take a number, we add 3 to it, and we store that back in number. So therefore, if we take a look at the value of number now, it should have a value of 8, because we updated it with a value of 3. Now rather than using that longhand form, there's a shorthand form, which is simply called plus equals. So this is basically a shorthand for adding a certain value to our variable and then storing that back in the variable. So here, for example, we are writing number plus equal 2. If we then take a look at the number, we can see we have a value of 10. And this augmented assignment operator is not only available for adding numbers, but also for subtracting them, multiplying them, and dividing them. Now at the end of our encrypt message function, we are then using the join function that we learned about before, and we are passing the ciphertext to it. The ciphertext, of course, is a list with individual strings as elements, and by calling join and the empty string, this is going to create a string, which is simply the concatenation of all the different elements which are included in our list. Now at the very end we have this somewhat cryptic looking statement: if name is equal to the string name, then execute the main function, and that ensures that when our program is run, the main function is executed automatically, and this is typically the start point for our program. Now this syntax also ensures that when we import our program as a module into another program, that we can start the main function as well, and our program runs and we can reference the different functions inside of it. Because otherwise it's going to use the file name by default, so transposition encrypt.py, and this way we won't easily be able to reference the included functions. And now that we understand how we can use the transposition cipher to encrypt messages, we found a way that's much more secure but also more complicated than Caesar cipher. Let's have a look at the practice questions. The first question asks us to encrypt some messages with paper and pencil using the key 9 for our transposition cipher. And they also provide the number of characters that have been provided. So the first sentence here, underneath a huge oak tree there was of swine a huge company, is the first string, which has 61 characters. And rather than doing that in code, we should actually encrypt the message by hand. Now to do that, we first need to have 9 columns, which corresponds to the key that we are using, key 9. And then we need to fit in 61 characters. Now, since we know that we need to fit in 63 characters, we can calculate how many rows we're going to need. If we have 7 rows, then 7 times 9 is 63. We can leave 2 fields empty, and the rest of those will be filled out with those characters. And after that we can get started taking our original string, and we need to type in 1 character per cell, and we can enter those characters row by row. We also need to make sure that we include the space characters. For those we would simply leave the cell empty. We also need to make sure that we include the comma, which is at the very end of the statement. Now the last 2 rows here, of course, will be left empty. So we could adjust the fill and, for example, gray them out. Now once we've done that, we can go ahead and we can read from the top to bottom for each of the different rows. And this is our encrypted message using the transposition cipher. Now if we type this out from top to bottom, we can see that we get this message here. And this is our encrypted message, and we can see it's not possible to tell what the original message was. So this is the approach we would take to encrypt a message using the transposition cipher. Now the second question is, in the following program, is each spam a global or a local variable? We can see spam is here outside of the function, so it's a global variable, and here we have it inside the function, so this would be a local variable. Next up, we can have a look at what each of the expressions evaluate to. We have a list here, and we reference the second index. So this means if we start from the top, 0, 1, 2, we would get back a value of 2. Let's confirm that in idle, and we can see that we get back that value. Next up, we have a nested list. So here we have 2 lists inside of another list, and we reference the zeros index. So that means we would get the first element back with the elements 1 and 2. Next up, we have another nested list. Here we are referencing first the first element with index 0, and then we reference the second element with index 1, so we should get back a value of 2, as we can see here. Next up, we have the string hello. We are referencing that as a single element in the list, and then inside of that string we are referencing the second character, so index 1, so we should get back an E, as we see here. Then we have another list, and we are using the slice syntax to start with the element at index 1 all the way up to but not including index 3, so we should get back the list with elements 4 and 6, as we can see here. Next up, we are using the list function to turn the string hello world into a list, and each individual character of that string should be its own element in that list. So let's verify that in idle, and here we can indeed see that we now have a list with each individual character, including the white space, being added as a separate element. And finally, we have a number of different nested functions. So here we're using the range function with a value of 10. So this will give us back the values from 0 all the way up to 9. We are turning that into a list. And then we are having a look at the element with index 0, so the third element. And that should give us back a value of 2. And we can indeed see that this value is then displayed. Next up, we should evaluate which value the following expressions evaluate to. So we use a len function with a list with 2 elements. So we should get back a value of 2, as we can see here. Then we have a len function called on the empty list, which should give us back a value of 0. And then we have the len function called on 3 elements that are empty. We should get back a value of 3. And then we have 2 lists that we concatenate together. We should get back one list with 6 elements added to it, as we can see here. We then, using the multiplication operation, to repeat the sequence 1, 2, 3 times and then adding the element 9 to it. So as we execute that, we can see 1, 2, 3 is repeated 3 times, and then at the end we have another element added to our list, the value 9. And finally we are using a boolean operation to check whether 42 is an element inside of the list. We can of course see it occurs 3 times, so this should evaluate to true, which we see here. And finally, the question is, what are the 4 augmented assignment operators? We know it's the value plus equals, minus equals, divides equals, and multiplication equals. So exactly those 4 operators that we can see here.
We learned a couple of new programming concepts, and we also learned how to encrypt messages using the transposition cipher. In the next video, we're going to learn how to decrypt messages using the transposition cipher. Feel free to subscribe to the channel to stay up to date, and see you guys in the next video.